All right, let's talk about something that you use every single second you're online, but probably never really think about. We're going to pull back the curtain on the unsung hero of our digital world, the database. It's the invisible force that takes all the chaos of information and turns it into perfect, beautiful order.
I mean, seriously, have you ever stopped to wonder? How does that website just know what's in your shopping cart, even if you close the tab and come back tomorrow? Or maybe more importantly, how does your bank know exactly how much money you have, down to the last cent, across every ATM and app in the world? Well, the answer to all of that is a really, really good database.
You know, before the databases we have today, the digital world was, well, it was a mess. It ran on these things called file-based systems. Just imagine every single department in your company has its own filing cabinet. And in each one, they've got their own copies of the same documents. It was pure chaos. The database flipped all that on its head. It created one central, smart filing cabinet that everyone could access and trust.
And the chaos of those old systems, it was a nightmare. Let's go back to that bank example. The loan department has its own files. The savings account department has theirs. This created insane amounts of data redundancy. The same customer address typed out in like 10 different places. And what happens when that customer moves? You get data inconsistency. Now they have different addresses in different files. Which one is right? Who knows? On top of that, you couldn't enforce basic rules, security was a joke, and forget about two people trying to update a file at the same time. It just wouldn't work.
So, into this chaos comes our hero, the database. But what is it really? It's not just a big digital bucket you throw data into. A database is a shared collection of data that's all related. The whole point is to create a perfect, tiny, digital model of some piece of the real world, whether that's a business, a hospital, or even a video game inventory.
But here's the thing. A database doesn't work alone. It has a super powerful sidekick called the Database Management System, or DBMS for short. The DBMS is the brains of the whole operation. It's the software, the gatekeeper, that lets you build the database in the first place, and then it manages everything: who gets in, what they can see, what they can do. It's designed to make everything convenient and efficient.
And with the DBMS, all those problems from the old systems, gone. It's like it has superpowers. It controls redundancy by making sure every piece of data lives in one and only one place. It enforces integrity with rules so you can't have a negative bank balance, for instance. It locks things down with a security system. And maybe most impressively, it lets tons of people use the data at the exact same time without creating a mess.
Okay, so we get it. Databases are awesome. They're essential. But how are they actually built? I mean, how do you design one from scratch? This is where things get really interesting.
The absolute best way to understand how databases are designed is to think about building a house. You wouldn't just show up with a pile of bricks and start stacking them, right? Of course not. There's a plan, a whole series of blueprints that take you from a vague idea to a finished, livable home.
And database design works the same way, in these 4 layers. You start at the top with the external model. This is just the user's view. It's the homeowner's wish list. I want 3 bedrooms and a big kitchen. Then, an architect takes that wish list and creates the conceptual model, the main blueprint for the whole database. Below that is the internal model. This is the super detailed construction plan that the DBMS itself understands. And finally, you get to the physical model. That's the actual foundation, the wiring, the nitty-gritty of how the ones and zeros are stored on a physical disk drive.
Now, when it comes to those blueprints, the one that absolutely dominates the industry is called the relational model. And the idea behind it is so beautifully simple. It says, let's organize all of our data into simple two-dimensional tables. You know, like spreadsheets. You have a table for customers, a table for products, and then you create links between them. That's it. But here's the catch. Even if you're using tables, you can still design a really messy, inefficient, and just bad database. So to make sure the blueprint is absolutely perfect, designers use a very special technique. The enemies of good design are these 3 little data-corrupting traps called anomalies. They're sneaky problems that can ruin your day. For example, a deletion anomaly is when you try to delete one piece of information, say that an employee is no longer on a project, and you accidentally wipe out all information about the project itself. These are the landmines we need to design our way around.
Okay, take a look at this table.
This is a classic example of what not to do. See how the project budget is repeated for every single person on that project? So if the budget for project P2 changes, you have to hunt down every single row with P2 and change it. Miss one, and your data is now inconsistent. And what if you want to add a brand new project but no one's assigned to it yet? You can't. This table is just begging for anomalies to happen.
So how do we fix this disaster? With a process called normalization. Honestly, the best way to think about it is like a deep, satisfying digital spring cleaning for your database blueprint. It's a set of rules you follow to break down big, messy tables into smaller, cleaner, more efficient ones that work together perfectly.
So the first step is to just pull that repeating project information out into its own table. Look at that! So simple. A project table with the project ID and its budget. Now the budget for any given project is stored in exactly one place. Redundancy gone.
And then the second table just keeps track of which employee works on which project for how many hours. It just links to that first table using the project ID. It never has to repeat the budget. And just like that, all those dangerous anomalies we talked about, they're physically impossible now. The design is clean, it's efficient, and most importantly, it's reliable.
Okay, final stretch. We have designed this beautiful, normalized, robust database. It's a masterpiece. But how do we actually talk to it? How do we put data in, ask it questions, and get answers back out?
We do it with a language called SQL, which stands for Structured Query Language. You can think of it as the universal language for data. If you want to talk to almost any relational database on the planet, you're going to be speaking SQL. It's the secret language that powers basically the entire internet.
And SQL really has two different sides to it. First, there's the Data Definition Language, or DDL. This is for building the house. You use commands like create table to actually build the structure you designed. Then there's the Data Manipulation Language, or DML. This is for living in the house, using commands like select to ask questions, insert to add new furniture, and update to rearrange.
And that's really the power of it all. At the end of the day, SQL is what lets you build the entire structure from scratch, handle all the day-to-day data management, and run incredibly complex queries that can transform mountains of raw data into actual, useful information. It's an unbelievably powerful tool.
So let's just step back and look at the journey we've been on. We started in this world of complete chaos, with messy file systems and duplicated data everywhere. Then we moved through the careful process of design, creating blueprints for our data. And we ended up here, in a world of perfect order, powered by clean, efficient databases.
So the next time you scroll through your social media feed, or buy something online, or check your bank account, you'll know. You'll know about the incredible, complex, and beautifully ordered system that's humming away silently in the background. Databases are, without a doubt, the foundation of our modern world. Thanks for watching The Explainer. So what hidden system that runs our lives should we tackle next? Let us know.